Today we're going to discuss arithmetic sequences. So far, you have defined a sequence and learned how to write the recursive rule for each sequence. An arithmetic sequence is a sequence. An arithmetic sequence is a sequence in which the numbers increase or decrease by a common difference. In other words, there is a constant rate of change or slope, so it is a discrete linear function. For example, 2, 4, 6, and so on is an arithmetic sequence because we are adding 2 each time. Therefore, the common difference, which is represented by D, is equal to 2. The common difference is just like the slope. You have already written the recursive form for arithmetic sequences. We had just not defined them yet to be arithmetic. When providing the recursive form, remember to always provide the first term. You will look at the sequence to define that, or you may have to actually figure it out. We'll do some examples of that. And also, a sub n equals a sub n minus 1. Remember that a sub n is the previous term plus the common difference. The recursive form is pretty simple to write, however, it can be very difficult to use. If you are asked to provide the 50th term, you would need to know the 49th term. But to know the 49th term, you would need to know the 48th term. And so it could be very time-consuming if you were asked to find a term that falls further into the sequence. So that is the point of having the explicit form. The explicit form may be a little bit trickier to write, but it is definitely a more useful form. The explicit form for an arithmetic sequence is as follows. A sub n, which represents whatever term it is you're looking for, equals the common difference times n minus 1 plus the first term. You can also simplify this and write it as a sub n equals the common ratio times n plus a sub 0. A sub 0 stands for the number in front of the first term. Essentially, this is y equals mx plus b. Hopefully that looks familiar to you. Let's try an example. Consider the infinite sequence 7, 3, negative 1. Is this an arithmetic sequence? For many, this would be an obvious answer of yes, because we are subtracting 4 each time. 7 minus 4 is 3, and 3 minus 4 is negative 1. Please keep in mind that not all common differences are as obvious. You may have fractions or decimals in which you would need to determine if there is indeed a common difference. So to do that, you can take the second term, which is 3, and subtract the first term. That would give you a common difference of negative 4. You would want this common difference of negative 4 to be the same between any terms. So you could also take the third term, which is negative 1, and subtract the second term, and negative 1 minus 3 is also negative 4. So since the difference between terms is the same, it's said to have a common difference of negative 4. So what do we do now? Now we would want to write the formula, the rule. So let's go ahead and do a recursive form since you've already done it. Remember, for a recursive rule, you need to first identify the first term. The first term is 7. To obtain any term, so a sub n, you must take the term before it, a sub n minus 1, and add, or in this case, subtract, the common difference, which is 4. So the recursive rule is a sub 1 equals 7, and a sub n equals a sub n minus 1 minus 4. The problem with this is if you were asked to find the 100th term, it would be very difficult because you would have to find all terms before it. And that's why the explicit rule is the better rule to use. the explicit rule, you must know the first term, which we already know, and the common difference, which again, we already know. You're just going to have to do a little bit more work. So the rule from the previous slide is a sub n equals the common difference, d, times n minus 1 plus a sub 1, which represents the first term. Let's fill in our common difference in our first term. A sub n equals the common difference of negative 4 times n minus 1 plus our first term, 7. That is the explicit rule. However, oftentimes the explicit rule is simplified. So to simplify it, all you have to do is distribute the common difference. So negative 4 times n is negative 4n. Negative 4 times negative 1 is positive 4. Add that 7. Combine your like terms of 4 and 7, so we get negative 4n plus 11. This is most often the way the rules are written. Notice it looks a lot like y equals mx plus b. We could have easily found 11 because it is the zero term. To find the zero term, you would just have to use the common difference backwards. So you would start with our first term, which was 7, and instead of subtracting 4, you would add 4, and 7 plus 4 is 11. So you can quickly come up with your zero term by working backwards. Here is why the explicit rule is superior. Now if you were asked to find the 100th term, or a sub 100, all you have to do is plug 100 in for n. So negative 4 times 100 plus 11. From here, it's just some simple math. You can do it by hand. You can use a calculator, whatever you prefer. So we have negative 400 plus 11, which would be negative 389. So the 100th term is negative 389. If we were to continue the sequence 7, 3, negative 1, 100 times, the 100th term would be negative 389. Now let's take a look at example 2. Write the recursive and explicit rule of an arithmetic sequence if the common difference is 7 and the 11th term is negative 31. They have given us the common difference of 7 and the 11th term, a sub 11, equals negative 31. In order to write the recursive rule, we need to know the first term and the common difference. To write the explicit rule, we also need to know the first term and the common difference. On this one, let's start off with the explicit rule. Keep in mind the explicit rule form is a sub n equals d times n minus 1 plus the first term, which we don't know. We're going to solve for the first term. We already know the common difference is 7. We have an n value. Remember that the n value is the subscript on the a. So right there, 11 is our value of n. So we're going to plug 11 in for n. We also know that a sub 11th, or the 11th term, is negative 31. So we're going to substitute in negative 31 for a sub n. And then plus a sub 1, and we're going to solve for that. This is just some simple math. Okay, we're going to do negative 31 equals 7. 11 minus 1 is 10. Negative 31 equals 7 times 10 is 70. And now to get the first term by itself, we must subtract 70 from both sides. So now we have that the first term is negative 101. Now that we've identified our first term and our common difference, both the explicit rule and the recursive rule should be fairly simple. Let's start with the explicit. Okay, we already know that it should be in the format a sub n equals d times n minus 1 plus a sub 1. So let's plug our numbers in. A sub n equals d, the common difference of 7, times n minus 1 plus, or in this case, minus our first term, because it's negative. It may look like that, or it may be simplified. So if we need to simplify, make sure you distribute the common difference to both n and minus 1. So 7n minus 7 minus 101, and completely simplified is 7n minus 108. The recursive rule. Provide the first term, which we discovered was negative 101, and then to find any term, we take the term in front, which is a sub n minus 1, and we add the common difference, so plus 7. And there you have it. You got your explicit and your recursive rule. If you were asked to find any specific term, you could use the explicit rule and plug in whatever term it is you're looking for into n. In our last example, we look at probably one of the most difficult types of problems you could see with arithmetic sequences. Determine the 50th term of an arithmetic sequence if the 16th term is 273 and the 28th term is 501. So they have given us that the 16th term, or a sub 16, equals 273, and the 28th term, a sub 28, is 501. We must figure out the common difference and the first term. We're going to start by finding the common difference. Remember that we said an arithmetic sequence is really just like a linear function, and that the common difference is just like slope. So we have talked about how slope is change in y over change in x. Well, we don't have x and y, but we do have a sub n instead of y, and we have n instead of x. So, just like for slope or rate of change, we're going to subtract our y values, or a sub n values, and we're going to subtract our x values, or n values. So our two y values are 501 and 273. Our two x values in the same exact order are 28 and 16. If you do a little bit of subtraction, you will get 228 over 12, and 228 divided by 12 is 19. That is our common difference. Okay, so our common difference is 19. Now our problem looks very similar to example number 2. We have the common difference, and we have two different terms that we could use to help us find the first term. So, in order to find the first term, we're going to use our basic explicit rule. A sub n equals d times n minus 1 plus the first term. Remember, we're looking for the first term, so we're not going to plug it in. We have just discovered that the common difference is 19. Now we have two choices for n and a sub n. We can use either 28 or 16 for n. I'm going to use 28, but you could easily use 16, and maybe a better idea because it'll keep your number smaller. But if I plug in 28 for n, then I need to plug 501 in for a sub n because the 28th term is 501. And now, again, simple math. We're going to do 28 minus 1, which is 27, and then 27 times 19, which is 513, plus a sub 1. We're going to subtract 513 from both sides, and we will discover that our first term is negative 12. So, if we're going to write our explicit rule, it's a sub n equals our common ratio of 19 times n minus 1 plus, or in this case, minus our first term. Again, you could simplify that. This problem, we're looking for the 50th term, so we are looking for a sub 50. all we have to do is plug 50 in for n, and again, do a little simplification. We've got 50 minus 1, which is 49. We're going to do 49 times 19, which is 931. And then we are going to subtract 12, and we get that our 50th term is 919. Hopefully these 3 examples have been helpful. Remember, you can watch this video as many times as you need to help you with future problems, whether on homework or preparing for your assessment.